been here before. Or you will be. They put a mask on your face or push something cold into your arm, and they tell you to count backwards from 10. You get to about 7. And then, nothing. No dreams, no time passing. You wake up and it's already over. We call that being under. We treat it like the lights just switched off. But a study published in Nature in 2026 found something that should genuinely stop you. While you were gone, while you had no awareness, no memory, no sense of anything at all, a part of your brain was still awake, still listening, and it was doing something nobody expected. Here's the finding, stated plainly. Under full general anesthesia, deep inside the brain, neurons were still processing language in real time, not just reacting to noise, actually sorting words, telling nouns from verbs, from adjectives, and then doing the part that's hard to sit with, predicting what word was coming next before it was spoken. That's the same basic move an AI language model makes when it guesses the next word in your text message. A brain that is, by every clinical measure, unconscious was quietly running that process anyway. Nobody would have guessed this out loud. For decades, the assumption was simple. Lose consciousness, and this kind of high-level thinking shuts down with it. This study says, maybe not. So where did this come from? Baylor College of Medicine. The lead author is a neurosurgery resident named V.G. Katlowitz, working in the lab of Dr. Samir Sheth. And the reason this study could even happen is unusual. The patients weren't volunteers lying in a scanner. They were 7 people already in surgery, being treated for severe epilepsy that medication couldn't control. To stop their seizures, surgeons were removing a piece of the temporal lobe, and that gave the team a rare window. For a moment, they had direct access to the hippocampus, a small curved structure buried deep in the brain that handles memory and learning. They slid in a probe called neuropixels. Thinner than a hair, it can eavesdrop on hundreds of individual neurons at once. Across those 7 patients, they recorded from 651 brain cells, while every patient was fully under, held there by propofol, one of the most common anesthetics on Earth. The first test was simple on purpose. Through speakers in the operating room, they played a steady stream of identical tones. Beep, beep, beep. And every so often, they slipped in a different one, an oddball. In an awake brain, that oddball triggers a little spike of attention. Wait, that was different. The question was, would an unconscious brain even notice? It did. Most of the recorded neurons responded to the tones, and a real chunk of them fired differently when the oddball hit. The brain, with no one home, was still flagging that one doesn't belong. But that's not even the strange part. Over the roughly 10 minutes of the test, the brain got better at it. The response to the oddball grew stronger, not weaker. Which means the unconscious brain wasn't just reacting, it was learning. Then they raised the stakes. Instead of simple beeps, they played real language. Clips from educational videos and storytelling podcasts to patients who were completely anesthetized. And they watched what the hippocampus did with actual sentences. It didn't treat the words as noise. The neural activity showed the brain sorting language by type, grouping nouns, verbs, and adjectives into different patterns of firing. It was parsing grammar under anesthesia. This is the kind of processing we assume needs a focused, awake, paying attention mind. And here it was, happening in someone who would remember none of it, in a brain that by every outward sign was switched off. And now the part that tips this from surprising into unsettling. The researchers found the anesthetized hippocampus wasn't just keeping up with the words as they arrived, it was running ahead of them. The neural signals showed the brain anticipating the next word in a sentence before it played. Predicting. This is called predictive coding. And until now, we tied it tightly to being awake and attentive. It's also almost exactly what a generative AI model does. Look at the words so far and compute the most likely word to come next. So picture it. A person, unconscious on an operating table. No awareness, no memory forming, and inside their skull, A small piece of tissue is quietly playing guess the next word and getting it right. Your brain running a little language model in the dark, whether you're there or not. Let's be careful about what this does and doesn't mean, because it's easy to overread. This is not proof that you're secretly aware during surgery. The patients had no conscious experience and no memory of any of it. That part holds. But it cracks open a much bigger question. We tend to treat consciousness and thinking as the same thing. Awareness on, mind on. Awareness off, mind off. This study pulls those two apart. It suggests sophisticated thinking, learning, parsing, predicting, can run without the light of awareness on at all, which forces an uncomfortable question. How much of what your brain does every day, it does completely without you? You get the finished thought. You don't see the machine underneath. And that machine, apparently, doesn't need you conscious to keep working. This isn't only philosophy. It lands in two very practical places. First, surgery. Anesthesiologists work hard to keep patients unaware, and this doesn't overturn that, but it does hand them new questions about what unaware actually means at the level of neurons. Second, and more hopeful, the team points to speech prosthetics. If a brain region we'd written off as too far from language can decode words and even predict them, that's a new place to tap in, a possible route to give a voice back to people who've lost one to stroke or injury. The same finding that unsettles you might also, down the line, help someone speak again. Now, the honest caveats, because they matter. This was 7 patients. 7. All of them had epilepsy severe enough to need brain surgery, so their brains aren't perfectly typical. They tested one anesthetic, propofol, so we can't assume it holds for every kind of sedation, and we definitely can't stretch it to sleep or coma, which are different states entirely. And it looked at one brain region. The researchers say all of this plainly. It's a striking result that still needs to be replicated and widened before anyone builds a worldview on it. But here's what's hard to shake. We like to imagine there's a clean line, awake on one side, switched off on the other. This study smudges that line. It says a part of you keeps reading the room, learning and guessing what comes next, even when you, the part that experiences things, has completely left the building. You were never as gone as you thought. So that's the study, one of the strangest findings about consciousness in years. If it rearranged something in your head a little, that's exactly why this channel exists. Subscribing is genuinely the one thing that keeps these videos getting made. So if you want more of them, hit it. And I'm curious, does it comfort you that your brain keeps working while you're under? Or does it unsettle you? Drop your honest answer in the comments. I read them. A like helps more people find this than you'd think. Thanks for watching, and I'll see you in the next one.